Hello and welcome to this video about magnets and magnetic fields. We're going to look at magnetic properties in this video, magnetic fields, how to draw magnetic field lines, and also magnetic versus geographic north. So I'm sure you all know this from playing with magnets on occasion. All magnets have a north and south pole. Magnetic poles always occur in pairs, and like poles repel each other, and unlike poles attract each other. In other words, two norths will repel, and two souths will repel, but a north and a south would attract each other. So how can a material become magnetized? First, let's talk about something called a permanent magnet. And a permanent magnet is simply a material that's been magnetized, and it creates its own persistent magnetic field. And let's say we have a piece of iron here that is not magnetized, it can become a permanent magnet by being stroked with a permanent magnet. If this is already a permanent magnet, it can be stroked and magnetized. Magnetism can also be induced by other means. For example, a piece of unmagnetized iron, if it's placed near a strong magnet, the piece of iron will eventually become magnetized. That process can be reversed by heating and cooling the iron or by hammering it. When we talk about different magnetic materials, we categorize them into soft magnetic materials or hard magnetic materials. Soft magnetic materials would be those that are very easily magnetized, but they also lose their magnetism very easily. Iron would be an example of that. Hard magnetic materials are difficult to magnetize, but they tend to retain their magnetism, such as cobalt and nickel. So magnetic fields, we represent by the letter capital B. A magnetic field is just a region in which a magnetic force can be detected. And we can represent the magnetic field using magnetic field lines. Those lines are showing lines of force. And magnetic fields have directions. So the magnetic field lines are always, the force lines are pointing away from the north poles and toward the south poles, because that's the direction that the north pole of a compass needle would point. Here's some examples of that. You can see that the magnetic field lines showing the lines of force are pointing away from north toward south in each of these situations here. Here is just a picture showing that if you sprinkle iron filings around a magnet, they will line up along the magnetic field lines. And the field lines that are at the points where they are closest together are the strongest. Here is just a picture showing how a compass needle indeed does line up along magnetic field lines. And the compass's north pole is going to point to this magnet's south pole. We have some conventions for representing the direction of a magnetic field when we draw these magnetic field lines. Simply a line with an arrow is in the plane of the page. An X will indicate into the page, and a dot will indicate out of the page. And this brings us to the idea of magnetic versus geographic north. The geographic north pole of Earth here actually corresponds to the magnetic south pole. So if we look at the magnetism of Earth, magnetic south is actually geographic north. If we use a magnet as a compass, the north pole of that magnet is going to point to the geographic north pole of Earth, which is in fact the magnetic south. We have a term called magnetic declination. It is the difference between true north, the geographic north pole, and magnetic north, because they are slightly different. This is the geographic north. You can see there's a little difference between geographic north and magnetic south. And from point to point on the Earth, the magnetic declination will vary slightly. In fact, if you are using a compass and you are traveling over the surface of the Earth, only near the equator will your compass needle actually rotate in the vertical plane as well as the horizontal plane. As you travel northward, the needle is going to rotate so that it points more toward the surface of the Earth, because it's pointing more toward that that magnetic south. Finally, when you arrive at a point just north of Hudson Bay in Canada, the north pole of that compass needle is going to point directly downward. That's because that site is considered to be the location of the magnetic south pole of the Earth, right here. And it's actually about 1,500 kilometers away from Earth's geographic north, North Pole. Similarly, the magnetic north pole of the Earth here is roughly the same distance from the geographic south pole as these are from each other. So it's only an approximation to say that your compass needle is pointing toward the geographic north, not really pointing directly at geographic north. Also, the source of Earth's magnetism isn't entirely understood. There are really large deposits of iron ore inside of the Earth, but Earth's liquid core prevents the iron from retaining any permanent magnetism because of its really high temperatures. So there's still investigation into the cause of Earth's magnetism, and maybe you could look into some of the theories and ideas currently right now for some advanced proficiency. Other ideas for advanced proficiency: what are magnetotactic bacteria? Explain some of their unique properties. Or what is the composition of magnetite and what civilizations have recorded investigating this mineral? How about looking into different sea routes? The compass was a really important invention for navigating at sea. What were the sea routes like before and after the invention of the compass? Or maybe you have some other ideas. Look forward to seeing what you come up with, and we'll see you in class.